Chapter 2.2, exercise 1 through 16. I'm going to go over the odd number problems here, and I'm going to use the graphing calculator just a little bit. Solve the following absolute value equations by graphing. And here we have absolute value of quantity x minus 3 plus 2 equals 5. And so we're going to graph each side without a calculator, and I'm going to show with a calculator. And so the standard form for an absolute value function is this: f of x equals a times quantity 1 over b times quantity x minus h brackets plus k. And so we have no a or b. I like usually combining this a over b out front. And so we have our vertex is going to be the point h comma k. And in this case, what that is going to be is h would have to be 3, comma, and k is going to be 2. So 3 comma 2 is going to be our vertex. And to go there, we go to the right 3 from the origin and up 2. So right there. I'm going to label that point here 3 comma 2. And next, we have a. There's no value of a out front, which means we have 1. So what we do is we have like a 90-degree angle. So to the right, like this, as we go toward infinity, and to the left, we're going to go like this. So we're going to be looking like this. And we saw by graphing here, we're depending on enough accuracy to get this correct. So that's the one side. The other side is 5. So we can go to 5. So here is 5 between 4 and 6. These are 2 apart. So I'm just making this a dashed line. So it looks like we are intersecting here, where at the point 0 comma 5, and then over here at the point 6 comma 5. So according to this, our solutions will be x equals, and I'm just going to put this in set notation, 0 comma 6. And to test our answer, we can put 0 or 6 in here and see what happens. Well, if we put 0 in for x, we're going to have 0 minus 3, but this negative 3 will be turned positive, so we'll have 3 plus 2 equals 5, check. And if we let x equal 6, we have 6 minus 3, which equals 3, and 3 plus 2 equals 5. The last thing I want to show, and it may be the only time I do this here, is in a graphing calculator. If we enter absolute value, I'll press second catalog, enter, we're going to put x minus 3, and outside here we're going to have plus 2, 1, and graph, we get this, and then we're going to put down below x equals 5, our y equals 5. So we have that. We see our intersection points here at 0, 5, and at 6, 5. And to show this analytically calculator, second trace intersect, and we can go right close to this first intersection, enter, enter, enter. So here we have an intersection where x equals 6, and we get the other, x equals 0. Second trace 5, and for this one here, we'll scroll over to close to the right, over here, enter, 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 x equals 6. So that is a graphing calculator verification. And there we have it. Next odd number problem, 3. We have -2 times quantity x plus 5 in absolute value for x plus 4 equals 2. Well, here we have a is equal to -2. So we're going to be turning an absolute value graph upside down and then stretching by a factor of 2. And we're going to have h is going to be equal to, we have x plus 5, so h is -5, and we have k is equal to 4. So, so we put a vertex. We have -5, 4. So here we go to the left, 5, -5, and up 4. So right here, I'm going to write this in as -5, 4. And then we are, a is -2. So what that is, in the rise over run department, we go rise. I'm just going to use the boxes here. So if we go down 2 and to the right 1, and we similarly do that to the left side, go down 2 and over this way, because that's what absolute value functions do. They have like the v, and then we follow that pattern down 2 over 1, and we're going to go where x equals 2 the other side. So I'm just going to go 1 more. So this is what the thing looks like. And then on the other side, we come down. Let's see if I can get that a little better at looking. There we go. Yeah. And we have equals 2, so that's going to be right here. Y equals 2. And so it looks like we have an intersection point here at -6, 2. I'll put -6, 2. And also at -4, 2. So according to this, our solutions are going to be x equal to -6, -4. Now how do we see if that's correct? Well, we can just plug in here, see if we put in -6, we get -6 plus 5 is -1. Well, -1 becomes 1 in here, right? And 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. Check. If we plug in negative 4, we get negative 4 plus 5 is 1. 1 times negative 2 is negative 2. Check. So these answers are checked. Now, so we're just doing these graphically now. Now solve algebraically. Now here's what you have to look for. If you have an absolute value bracket here by itself, and that is equal on the right side to a positive number, you're going to have two solutions. If instead of being a single positive number on the right side, you have, if 0, you have one solution. That's when you solve for your absolute value bracket. If less than 0, no solutions. And we're going to explain why that is here also. Okay, so the absolute value of 2x equals 3. So what that does, we have two possibilities. We have either 2x is equal to 3, or 2x is equal to negative 3. And if we solve this one dividing by 2, we get x is equal to 3 over 2, or divided by 2, x is equal to negative 3 over 2. So 3 over 2 would be right here, 1 1/2. And then on the other side we have negative 3 over 2. Those would be our solutions. And we've graphed them. And you can plug these back in. If you multiply here, you'll get negative 3 or 3, depending on which solution. Next, our number problem 7. So I'm going to go ahead and rewrite this down here, just give myself a little room to work. So plus 2 equal to 3. So we're just going to go about solving this. We subtract 2 from both sides. We get 3 times absolute value of 2x minus 3 is equal to 1. And since, just to mark, since 1 is greater than 0, we have two solutions. So next we go about dividing by 3, So we get either 2x minus 3 equals 1/3, or 2x minus 3 equals negative 1/3. And then we can go ahead and add 3 to each of these equations, each side. And since we're in thirds, I want to take 2x minus, I'm going to change 3 into 9/3. And if we add 9/3 to both sides of this equation, we get 2x, I'm going to work to the right here, 2x equals 1 plus 9 is 10. So 2x equals 10/3. And if we divide by 2, divide by 2. We're going to get x is equal to 10/6. And 10/6 will simplify to 5/3. So that's one of our solutions. And these are set up in 5/3. Let's see, thirds. 1/3, 2/3, 3/3, 4/3, 5/3. So there is one of our solutions, 5/3. And then we're going to go ahead and test our answers too. And now we have 2x minus 3 equals negative 1/3. What I'm going to do for this is bring it up here to leave some room to work below. Okay. Now for this one, we're going to change. I'd rather have a skinny pen. There we go. So we have 2x minus 9/3 equals negative 1/3. And if we add 9/3, we're going to get 2x is equal to 8/3. And divide by 2, we're going to get, I'm going to work to the right, x is equal to 8/6, which simplifies to 4/3. So here we have 4/3. That is another solution. And we can just test these out pretty quickly. If we plug in 5/3, we're going to get 2 times 5/3, which is going to be 10/3. Absolute value. Okay, 10/3 minus 3 is 1/3, and 3 times 1/3 is 1 plus 2 is 3. We plug in 4/3, we get 2 times 4/3, which is going to be 8/3 minus 9/3. We get negative 1/3. Negative 1/3 times 3, that's going to be positive 1/3. 1/3 times 3 is 1. 1 plus 2 equals 3. Check. These are the answers. Next on our problem. In this set, isolate the absolute value expressions in the following equation to determine if they can be solved. If so, find and graph the solution or solutions. If not, write no solution. Now, in this case, we have 1/4 absolute value of quantity x plus 2 plus 7 equals 5. If we subtract 7, we get 1/4 absolute value of quantity x plus 2 is equal to negative 2. And if we multiply both sides of this equation by 4, we get on the left side quantity x plus 2. And on the right side we get negative 8. Now we've isolated the absolute value expression. Is it possible for the absolute value of anything to be negative? No. So since absolute value cannot be negative, no solution. And then, of course, we don't have to graph this at all. Next on number problem, 11. Same technique. Okay, we have, first thing we're going to have to do is we have 2 times, we have that in parentheses. We're going to distribute here to inside. So I'm going to write the distributed form down below. So we're going to get 2 times the absolute value of x plus 4. And then we're going to have plus 6 is equal to 6. And then if we continue to solve, we subtract 6 from both sides. And so we're going to get 2 times the absolute value of x plus 4 is equal to 0. Well, we're going to have exactly one solution. If we had a positive number, we'd have 2 solutions. On the right side, if we had a negative number, we'd have none. If we have 0, we have exactly one solution. So we're going to divide by 2. We're going to get absolute value of x plus 4 is equal to 0. And what that means is we go 2 directions. We have x plus 4 equal positive 0, and x plus 4 equals negative 0. Well, how far is 0 from 0? They're both the same thing. In each case, we get x is equal to negative 4. So one solution, x equals negative 4, and then we're going to graph this on our number line. Negative 4. Okay, next on our problem, 13. Same thing. We're going to take absolute value of 23x minus 4 plus 2 is equal to 1. If we subtract 2 from both sides, this equation, we get absolute value of 3x minus 4 is equal to negative 1. Okay, I think we're looking like problem 9, aren't we? This absolute value, the left side of this equation, can never be negative, let alone negative 1. So since absolute value cannot be negative, we say there's no solution. I hope you'll notice that these, as far as the difficulty of this section, not at all, except basic algebra skills and simplification skills. That's it. Okay, the last one I want to do in this exercise set is we have this right here. I'm going to rewrite below to give room to work. So we have 2x plus 5. And then we have minus 3 here. That's all inside absolute value bracket. We have plus 2 is equal to 6. So if we subtract 2, we get 2 times quantity x plus 5 minus 3 is equal to 4 on the right side. And I hope you can see by this point that we have how many solutions. If you said 2 solutions, you're right, because we have equal to a positive number on the right side. So we're going to set this up in 2 directions. We're going to write this as 2 times x plus 5 minus 3 is equal to 4. And over here I'm going to write 2 times x plus 5 minus 3 is equal to negative 4. And we'll just solve each equation. On the left one we add 3. So we're going to get, what I'm going to do is I'm going to do 2x, 2 times x, so 2x plus 10 So I distributed here is equal to 7. And subtracting 10, we have 2x is equal to -3. So x is equal to -3 over 2. And test this out. We're going to have this thing be equal to 4 here. Well, we'll do that right now. If we have -3 over 2, -3 over 2 plus 5, well, 5 is 10 over 2, so -3 over 2 plus 5, that's going to be 7 over 2. 2 times 7 over 2 is 7. 7 minus 3 is 4, and 4 plus 2 is 6. Check. Let's do this one on the right here. We're going to add 3 to both sides, so we get, I'm going to add 2x plus 10, right? That's the distribution here. 2x plus 10 is equal to -1. And if we subtract 10, we're going to get 2x is equal to -11. Dividing by 2, we get x is equal to -11 halves. Let's check that out. If we take -11 halves, -11 halves is going to be plus, so -11 halves plus 10 halves, that's -1 half. So -1 half times 2 is -1. -1 minus 3 is -4. -4, absolute value of -4 is +4, and 4 plus 2 is 6. Check. So these are valid solutions, and we're going to place them here on the number line. So x equals -3 over 2. Here's -3 over 2. That's going to be -1.5. I'll put here -3 over 2. And the other solution is -11 over 2. So that's going to be right here. -11 over 2. So that's it. Let me rewrite this one a little more legibly. -3 over 2. That's a little more legible. All right. So that's it. I'll leave you to work out the number problems. Good luck, and thanks for viewing.